Woo! That last one was a doozy. Sorry, that one got away from me here. But on to this other typical example. So we're over here. You can ignore all this stuff right now. All right, so hopefully you copied down that example. This is the typical type of absolute value inequality you will be solving. So first, of course, you isolate the absolute value by doing the inverse operation. Now that it's isolated, I split it into two equations, just like equalities. But you remember that when you split it into two equations, I have an 8 and I need a negative 8. Well, that negative 8 came from multiplying the outside by a negative 1. So really, I also have to flip the inequality. So that is a key thing here. I got a negative and the inequality symbol changes. So there's two things different in that second equation. Make sure you take note of that, all right? Don't be that kid that makes that mistake over and over. All right, so now I solve each. Add 2 to both sides. Same over here. Now I have, it was a greater than to start with, so it's going to be all the values outside the two boundaries, or if you just graph these two, you can see that it's all the values pointing outward. All right, so that's your typical kind of absolute value inequality type of problem. One more, what's called a tolerance problem. Tolerance because we want to, produce or manufacture things within certain tolerances, right? You can make, you make in pipes or pipe fittings, there's a couple thousandths of an inch tolerance for some of those, right? Medical equipment, super high tolerance levels. And then, if you're cutting the trim on a baseboard, you got, maybe an eighth of an inch or something that you can deal with, depending on where you're looking at. So tolerance problems are when you're allowed plus or minus a little bit of a value. Right. So another thing would be like voting, right? Like 50% voted this way, plus or minus 3%. So the generic format is x minus what your desired value is, and then greater than or less than, depending on whether you're trying to be inside or outside certain tolerances, and then whatever that tolerance level is, or whatever that margin of error is. So for our problem here, which you've read already, it's going to be x minus the typical or normal value, which is 224. And then we want to be within that, so it's going to be a less than. And then it was 6 seconds. So that is the setup for this tolerance problem, which you could then solve. But I'm going to spare you. You guys can do it tomorrow in class. Have a nice day.